Hi guys, I Aziz welcome you to CoedMaster. With this video, I am starting a brand new series on object-oriented programming. So let's directly come to the main point, that what can you expect from this series. So my friend, in this series, you will get to learn what is object-oriented programming, why we need object-oriented programming, what problem it solves, and on top of that, you will get to learn all the concepts of object-oriented programming like inheritance, polymorphism, abstraction, and encapsulation. We cannot deny the fact that people find object-oriented programming a bit daunting and intimidating. But I will explain all the concepts of object-oriented programming in such a way that you will never forget the concept after watching this series. And not only that, I'm also make sure that you will never have to go to any other video to learn object-oriented programming after watching this series. So as this is the first video of object-oriented programming, in this video we are going to learn what is object-oriented programming, a little bit history of object-oriented programming, and what is the problem that is solved by object-oriented programming. So if you are willing to learn object-oriented programming, then make sure to watch the entire series in order to learn what is object-oriented programming and all the concepts of object-oriented programming. So without wasting any time, let's get started. Alright guys, let's begin this video with this fact that object-oriented programming is highly inspired from real-world entities. Yes guys, this is a fact and I recommend you to remember this fact because by the end of this video, you will agree on this fact that object-oriented programming is highly inspired from real-world entities. So in order to understand object-oriented programming, let me take you back in time when there was no object-oriented programming. I mean to say, let me take you to pre-object-oriented era. Now you might be wondering that if there was no object-oriented programming, then how people used to develop software back then? Well, when object-oriented programming was not there, there was a concept of procedure-oriented programming. Now, what is procedure-oriented programming? Well, it is a way of writing a program using procedure. Now you may ask that what is procedure? So guys, procedure is nothing but it's a function. And what is function? Function is nothing but it's a set of computational steps that is applied on the input. Okay? So you can consider that procedure is nothing but a black box. So we can pass input into this procedure. It will apply some computational operation on that input and produces an output. So we call this black box as procedure. Okay? And in the modern term, you can understand this as function. Okay? Now you understand that what is procedure-oriented programming. It's a way of writing programs using procedures, and procedure is nothing but a function. Now let me show you the architecture of how procedure-oriented programming looks like. Okay? So in procedure-oriented programming, we have a global data. Okay? And then we have procedures like procedure 1, procedure 2, procedure 3, and procedure 4. Now in procedure-oriented programming, all the procedure have access to this global data and all the procedure can manipulate this data. And not only that, if procedure 1 want to communicate with procedure 3, they can communicate with each other. There is not a problem. So if you look at this diagram carefully, we have two components here. One is data and one is procedure. Okay? Remember this point. So this is how communication was happened in procedure-oriented programming. You can see over here is that in procedure-oriented programming, more emphasis is given to procedure than data. But guys, if you look at this type of architecture, this architecture has two major problems. So the number one problem of this architecture is every procedure has access to this global data. Okay? Which means we have uncontrollable and unprecedented access to data. Any procedure can access and update this data or manipulate this data. And the second major problem of this paradigm is we cannot control who can access data, which means if we want to restrict procedure 1 from accessing this data, we cannot do it. If we want to restrict procedure 4 from accessing this data, we also cannot do it, which means all the procedure can access this global data and manipulate this data. So these are the two major problems that exist in this paradigm. Now this is the end of procedure-oriented era, and here comes the era of object-oriented programming. So in object-oriented era, this is where the object-oriented programming comes into picture to rescue us. So the object-oriented programming addressed these issues very cleverly and solved it at a significant extent. Now the question over here is, what is meant by object-oriented programming, right? So it is a paradigm to write a code, or we can say in another way that it is a way of writing code on the concept of objects. So just like procedure-oriented programming is a way of writing a code, similarly object-oriented paradigm is also a way of writing a code using objects. Now this brings us to the next question, that how it solved the above problem. So let me show you. So first of all, object-oriented programming is completely against the global data. So which means we do not have global data in object-oriented programming at all. Now the question arises that if we do not have global data, then how are we going to manage data? So guys, object-oriented programming has cleverly solved this problem by combining data and behavior into a nice package called object. So unlike procedure-oriented programming where there is a global data and all the procedure are operating on that data, in object-oriented programming we have objects, and this object encapsulates data and procedure. So which means we do not have global data, we only have local data which is associated with object. Now this form of architecture solves both the problems. Now if we have multiple objects like 5 to 10 objects, then as we do not have global data, then none of the object can access the data of each other, which means we have now controllable and predictable access of data. And second thing, one object cannot access the data of another object without the permission of other object. So that is why we have control over who can access data, which means if we have two objects, object 1 and 2, then object 2 can control whether the object 1 can access object 2 data or not. So I hope you understood that how this paradigm encourages using of local data instead of global data, and this paradigm is completely against the use of global data. So in this paradigm we use objects, and this object contains data and procedure. Now let's move on to the next topic. So there are different terminologies that is used in object-oriented programming. So in object-oriented programming, we call this data as attributes and we call this procedure as methods. So when data and procedure resides in object, we call it attribute and methods. And in object-oriented programming, the combination of attribute and method is called encapsulation. Now let me show you how communication is happened in object-oriented programming. Okay, so let's say we have one object here, object 1, and we have object 2 here. So as I said, object contains attributes and method. So this object has one attribute or data, and this object has method 1, method 2 and method 3. Similarly, this object also has attributes and data, and this object has method 1, method 2 and method 3. Now let's say this object wants to communicate with this object. So how can it be done? So in case this object wants to communicate with this object has to call method 1 in order to communicate with object 2. And similarly, if object 2 wants to communicate with object 1, this object has to call method of object 1 like method 3 or method 2. Now what about data? Let's say object 1 wants to change the data or manipulate the data of object 2. In that case also, object 1 has to call the method of object 3 in order to change or update data. And the method 2 of object 2 will validate whether the method 3 of object 1 is allowed to make a change or not. So this is how we have full control over which method can call which object and which object can access the data of which object. Now if you look at this architecture, unlike procedure-oriented programming, the emphasis is given on procedure. In this paradigm, emphasis is completely given on data, okay, and not the procedure. So this is how objects can communicate in object-oriented programming using methods. So long story short, object is a building block of object-oriented programming. So guys, you may be wondering that why object? Why not something other than object? Well, the reason is simple, that people already think in terms of object. And that is why object-oriented programming was born. Okay, let me understand this concept using this example. So if I ask you that on which device you are watching this video, so your answer would be that you are watching this video on laptop or desktop or mobile phone. So let's assume that you are watching this video on laptop. Okay. Now if I ask you that what is laptop, so your answer would be laptop is a device. But if I ask you that in generic term, what is a laptop? So laptop is nothing but a real world entity, right? So because you can touch laptop, you can feel laptop, you can see laptop, it's a real world entity. Now if I talk about this entity is not a whole entity in its own. It is made up of small entities, right? For example, your laptop is made up of display, mouse, keyboard, processor, RAM and motherboard. So all these are the small entities by which this large entity is made of, right? Now in terms of object-oriented world, we call this entity as object. So which means in object-oriented programming, object is nothing but a logical real-world entity, right? Let me understand the term object with these few examples. So as we saw above, that object has attributes or methods, right? And we also call attribute as state and method as behavior. So we can say that object has state and behavior. Now let's understand this concept of object with this example. So let's consider a keyboard. So keyboard is a real world entity, and in object oriented programming we can call it an object. Okay. Now keyboard has some attributes, like it has keys, right? From A to Z or 1 to 3 or special characters, like, and keyboard also has behavior, right? And what is the behavior? It's a typing behavior. So using keyboard we can type. Okay. So keyboard, so to say, behave in some form. So that is why we can call that keyboard is an object. Okay. Now let's take the another example. Let's say display. If I talk about display, display also has attributes, and these attributes are pixels, right? Because your display consists of pixels, isn't it? Okay. Now what about the behavior? Now your display also has behavior, and that is you can turn on your display and you can turn off your display. So display can be turned off and display can be turned off. So that is a behavior of a display. So similarly, all the objects over here has some attributes and some behavior. I hope this is clear to you. So this brings us to the next question, that what we do in object-oriented programming. So guys, in object-oriented programming, we write programs or software using real-world entity or object. Then those objects communicates with each other using methods. So this is the actual purpose of object-oriented programming, that we convert our software into real-world entity, and then we build software around that real-world entity or an object. So now again we came to this fact that object-oriented programming is highly inspired from real-world entities, right? And I explained you in a very systematic way that how real-world entity map with the object in object-oriented programming. Now this brings us to the next question, that what can we do with object-oriented programming? Well, we can build highly flexible, extensible and maintainable software using object-oriented programming. Now you may ask that why can we build flexible, extensible and maintainable software? Let me take you the same example as I explained above and explain this flexible, extensible and maintainable concept using this example. Okay. So first thing is flexible. So how can we build the flexible software, right? So let's understand this concept using this laptop. So as we know that laptop has one RAM, okay? So let's imagine that tomorrow your RAM gets broken. Then what you would do? So you would simply replace the RAM. This is what you do when your RAM gets broken. So we can say that the laptop is so flexible that we can pull out RAM at any point of time and put another RAM into the laptop. So this property says that the laptop is very flexible to change, right? Now the next property is extensible. So in terms of laptop, we can say that this laptop is very extensible. And why is it so? Because our laptop has few USB ports. So using that USB port, you can connect any device into the laptop. Like you want to connect the extra mouse or extra keyboard or extra display. So which means you can extend the laptop up to some extent, and it is very easily to extend the laptop using some peripheral devices. So which is why we say that this device is very extensible. Now the third term we are going to discuss is maintainable. So because of these two properties, that it's a flexible and extensible, it is very easy to maintain this piece of hardware. and it is easy to modify, extend and troubleshoot. And why is it so? Because of these two properties. Now just imagine that if this laptop was not made up of all these small entities and it was just a single entity on its own, then it would not be possible to pull out the RAM and put the another RAM, because that machine is a completely single unit in itself. So we cannot change or extend the behavior or the properties of that machine, right? So because of the properties of flexibility and extensibility, this is very easy to maintain this machine, which means we can easily modify, extend and troubleshoot this machine. Now we can use the exact same concept in object-oriented programming also. Using object-oriented programming, we can build flexible, extensible and maintainable code so that we can extend the code at any point of time. Our code will be very flexible to change. So which is why we can maintain our software very easily without putting a lot of efforts. Now the question over here is, how can we write flexible, extensible and maintainable code? So guys, this is where the concept of object-oriented programming comes into picture. And these concepts are inheritance, polymorphism, abstraction and encapsulation. And we will see all of these concepts in upcoming videos in detail. So I will explain all the concepts using real world example so that it will be very easy for you to relate and remember the concept for a long time. Now again we came to the same fact, and the fact is object-oriented programming is highly inspired from real-world entities. So guys, always remember this fact that object-oriented programming is highly inspired from real-world object or real-world entities. So what do we do in object-oriented programming? We get the inspiration from real-world entities and then we try to imitate all the real-world entities into objects, and then we build softwares using that objects. So guys, I hope that you also agree with this fact that object-oriented programming is highly inspired from real-world entities. So I hope you understood that what is procedure-oriented programming, how it works, and then we discussed about object-oriented programming, and I hope you understood what is object-oriented programming, what are objects in object-oriented programming, and how object-oriented programming actually works, and what are the terminologies of object-oriented programming, and how can we build flexible, extensible and maintainable software using object-oriented programming. In upcoming videos, we will learn the core concepts of object-oriented programming along with the real-world examples. So guys, this is all from my side for this video. If you have learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.